hardest part of inverses is not finding the inverses, because it's 2 steps. You switch the x and the y and you solve for y. That is never the tough part for inverses. The tough part for students for inverses is always this domain business. You know, what do I do with this whole domain business? Well, you've got those little lines off to the side on each page, right? So I'm going to remind you of what we do to talk about domain, because we only have a couple of restrictions. And that's going to be whenever we have an even root. So an even root. If that happens, then we have to take whatever this is and make sure that it comes out greater than or equal to 0. So that's one time when we have to restrict the domain. The only other time we restrict the domain is when we divide. So we're either looking at even roots, this is number 1, or we're looking for division because you can't divide by 0. So the objective of finding the inverse, it really isn't the tough part of the objective. The part of the objective that's not stated is going to be talk about the domain. You know, see what the domain is. So for 4a, they give us g of x. And it says, what are the domain and range of g? So I want you to look at that one. Do you see any even roots in that problem? Do you see any division? So our domain is going to be all real numbers. And if we can put all real numbers into this thing, well, then it's going to kick out all real numbers, because this is a line, because this is 4x to the first. So our range of g is also going to be all real numbers. I need Chromebooks closed. You need to be paying attention to the lesson, please. Thank you. Alrighty, so we've got the domain and range of g. Now, once you have that, then the domain and range of the inverse becomes super easy, because all you do is flip them. You know, the domain of one becomes the range of the other, and the range becomes the domain. But we still have to find the inverse. So let's go to B. What's step 1 to find an inverse? Switch the x and the y, but there's like a step 1/2 here, because which of these is really y? Yeah, so we're going to go ahead and think of this as y equals 6 minus 4x, and then we're going to switch the x and the y. Okay, there's step 1. What's step 2 for inverses? Solve for y. So how do we get it by itself? Subtract 6. Pay attention. What do we do now? Divide by -4. And like we talked about yesterday, if they're going to have us graph or something, then we're going to go ahead and make this look like y equals mx plus b. So we're going to put a little 1 right there and say this will be -1/4 x plus, because negative and negative, when you divide that, you get a positive. And we'll go ahead and take 6/4 and reduce it to 3/2. And make it -1/4 x plus 3/2. Now, we're not done with it, because they said, what is the inverse of g? And then C is, well, let's go ahead and call this g inverse, because that's how they're referring to it all the time. And what's its domain and range going to be? Well, again, we don't have to do any thinking. All we have to do is say, well, it was all reals before, so when I flip it, it's going to be all reals. So the domain of g inverse, all real numbers, and the range of g inverse, all real numbers. When we were doing the math, we never had to take an even root. We never had to do any division by x. So there wasn't any new restrictions. And then the last one says, is g inverse a function? And explain. What does this look like if we graph it? It is a line. Is that going to pass the vertical line test? Did we graph a line? Yeah. So, B. Yes. Passes the BLT, the vertical line test. It's a line. It's x to the first, which tells us this is going to be a line when we graph it. So, that is out of the way. And now, there always seems to be an exception. The rules to finding an inverse. Step 1, switch the x and the y. Step 2, solve for y. However, you can't do that in word problems, because in word problems, they stand for something. The variables stand for something. So when finding the inverse of a real-world problem, we can't switch the variables. We can't make the x the y. Because if you look at these, area is not even in the same set of dimensions label as radius is. Radius is just going to be a unit of length, and area is going to be square units, so you can't do that. So what do? Well, you just solve for the variable that's not already solved for. So we simply solve for the independent variable, the input. So whichever one you would normally say, oh, I'm going to put a radius into this formula, well, just solve for that one. That will give you the inverse. So with area equals pi r squared, we say, all right, I got to get that r squared by itself. I better divide both sides by pi. Okay, now I have to figure out how you undo squaring. How do you undo squaring? Square root. And normally we would say plus or minus, but we know this is the radius of a circle, so we know it's going to be plus. There it is. So you just solve for the variable that's not already solved for when you need to find an inverse of a word problem. How do you do it? Now, why does this bother people? Because there's lots of variables, you know. And now it seems like there's just a boatload of variables whenever you want to solve a formula for something. But just remember, use inverses to move everything over to the other side. So this one says, finding the inverse of a formula, and the function d equals 4.9 t squared represents the distance d in meters that an object falls in t seconds due to Earth's gravity. Find the inverse of this function. How long in seconds does it take for a cliff diver shown to reach the water below? All right, so we're starting here. The question asked us about time. So we want t all by itself. So we have to figure out, how do we move everything over and get t by itself? What should we do first? Divide both sides by 4.9. Almost there. How do we get t alone? Square root. Now, that might make us a little nervous. You know, the square root of d, we're just going to have to leave that right there. But hang on a second. Square root of 4.9, that might be something nice. Why do I say that might be something nice? Because 49 is a perfect square. You do second square root of 4.9, and you realize, oh, well, that's not as nice as I first thought it was. So maybe we just leave it. Yeah. Did it look nice when we actually found the square root? Then why use it? Wouldn't this be much easier to punch in than square root of d divided by 2.213594362? So we just stop there. We want a nice looking formula. So initially we think, well, 49 is a nice perfect square, so 4.9 must be too, but it didn't work that way. So there we are. So there's our formula. Now why didn't I put a plus or minus on this one? It's time. You're never going to tell anybody it took a negative 3 seconds to do something. You're just not. So now it says, let's use this. We've got this crazy person jumping off a cliffs over here. And they're going to jump off 24 meters. So I guess the real question is, will they be able to scream all the way down, or are they going to have to like take a breath? You know, how long is this going to be screaming? So the distance is 24 meters. We've got 4.9. And again, if you don't have a calculator today, don't worry about it. You can just watch on the TV screen up there. So I want second square root of 24 divided by 4.9. 2.21 seconds. So let's see. Start screaming. Yeah, it's only 2.2. They won't need a second breath. They'll be just 2.21 seconds.
That in the picture looks super composed though. I don't think it's great.
He should be. Maybe he was the first time he did this. But, you know.
It looks like he's about to do a flip or something.
Yeah. That's insane. That is insane. All right, let's look at number 5. The function d equals v squared over 19.6 relates the distance d in meters that an object has fallen to its velocity v in meters per second. Find the inverse of this function, and then we'll do the cliff diver thing again. So, help me out. How do we get v? Then, square root. Don't suppose we got lucky and the square root of 19.6 is something nice, do you? We'll take a peek, but probably not is right. Second, square root. Somebody already checked it out? It's no good. That's ugly. Let's just leave it as this. Alrighty. What is the velocity of a cliff diver in meters per second as he enters the water? Okay, well, what did we know about D from the picture? Well, let's put her in there. Let's see. So let's see just how fast that belly flop is going to happen. Second square root, 19.6 times 24, 21.7 meters per second. Ouch! It's near. Yeah, that's hitting the water pretty doggone fast. So, like I said, this is our realization that word problems are sometimes the exception. You can't switch D and V. They are for two different things. One's distance and one is speed, so you can't do that. But for everything else, we switch the x and the y and we solve for y. That's what we do. So, you know that for any function f, each x value in the domain corresponds to exactly one y value. We talked about that yesterday. For every input, there's exactly what?
One output.
One output in the range. For a function to be super special, and this is one of those things that when you get to calculus, there are a lot of math pieces you can do with a function that's called one-to-one. Now, what it means to be one-to-one is for every input, there's exactly one output. And for every output, there's exactly one input. It has to work both ways to be one-to-one. So you can't just say, oh, it was a function when I put it in there. No, no, no. Check it the other way, too. And the other way is the inverse. So they both have to be functions. So notice this one says, you know what? Here's what you got to check. A to B, one output. B to A for the inverse, one output. So it has to work one-to-one. So, key concept is called the composition of inverse functions. Because you can't do calculus on functions sometimes. There's certain calculus you can't do unless they are one-to-one. So how does a person get to know that the functions are one-to-one? Well, this is how. If f and f inverse are both a function and an inverse function, when you do f inverse of f, you should get x. And when you do f of f inverse, you should get x. If you don't, then it's not one-to-one. So that's how we're going to know we have a one-to-one function when we do this. And it says, this says that the composition of a function and its inverse is essentially the identity function. Identity of x equals x or y equals x. So f and f inverse, if they're inverse functions, I like this. They're telling us what the answer should be. It's like knowing before you do the math what you're supposed to get. That's always helpful because then you know if you're right or not. So if we do the composition, we're supposed to get x. That's it. That's all that's supposed to be there when we're done. So let's check this out. This says, if this is f of x, what's its inverse? Okay, well I have to remember that that's y. So I'm really starting with this. And then what's the first step for inverses? First step, switch the x and the y. Oh boy, problem. We want to solve for y and it's in the denominator. You can't do that. You have to figure out how to get it out. Huh. Oh, I know. If we slap a 1 under this, we can cross multiply. Because now it's a proportion. That'll work out pretty cool. So x times y minus 1 equals 1 times 1, which is just 1. Okay. Now your algebra instinct should kick in. What do you want to do? When you see parentheses with something outside them, what do you want to do? Distribute. Let's distribute. Now I can focus on getting y by itself. How do we do it? This is where I said people get confused because there's so many variables. If this were a number, wouldn't you just add whatever it is? Then let's do that. Let's add the x. How would you get rid of whatever's in front of the y? You would divide. And then finally, they didn't want us to call it y. They said make it fancy. Make it f inverse of x. All right. So far, so good. Except, they're going to have us start doing math with this. Why is that a problem? Because both of these had division, which means there's a number we can't use in them. So we better stop and think about domain. So this was our original. What number would be bad in that equation? 1. Because then on the bottom it would say 1 minus 1, which is 0. So you can use whatever you want in this formula. Just don't try to put a 1 in. That's bad. Not going to work. Well, then we wrote the inverse. That's down here in the green. And we still had ourselves some division. But now there's a new number that's bad. What number, if we put it down here, would make us divide by 0? Yeah, you're overthinking. It's 0. So x can't be 0. So what we have to check each time is which one of these are we putting stuff into, and can we put the number they're giving us into that function. Now this one says f of the f inverse of 1. So where am I supposed to put the 1 first? Into the inverse. Can we put 1 into our inverse? What's the only number we can't use in our inverse? 0. So we're okay. Let's put a 1 in here. 1 plus 1 would give us 2. 2 over 1 would give us 2. So doing this, we got a 2. Now what do we have to do with that? We already put it in f inverse. Put it in f. All right, let's go up here. Can we put a 2 into this formula? Yes. 1 over 2 minus 1. Now what does that say? It says we put it into f inverse and f, and we got a 1. And what was x in the first place? It was 1. We got it right back. Cool. So let's try this one. Which one am I putting this into first this time? This one has to go into f. Can you put 1 into f? No, we're done. We have to say this is undefined. You can't do it. Remember, 1 was the one number we could not put into f because it would have us dividing by 0. So we can't do that So when we're thinking about the domain for composition, we have to remember, hey, this is a number that can go in here, this is a number that can't go in here. So let's look at this one. So before I'm even starting, I'm already thinking domain here, and I'm going to change that to a y. So it's going to be y equals 4 over x plus 2. What number would be bad if we put it in for x? Negative 2, because negative 2 plus 2 would be 0. So we can't use negative 2 in the original. That's a no-no. Well, now they want us to find the inverse. What's the first step to finding an inverse? Switch the x and the y. Second step. Solve for y. You guys lead me through this one. We did one very similar to this. What should we do? Slap a 1 under there. Why do we do that? Now we have two fractions. How do you solve that? Cross multiply. X times y plus 2 equals 4. Now what? Distribute. Now we start thinking, okay, I've got to solve for y. Subtract 2x. Doesn't matter if you write that 4 minus 2x or negative 2x plus 4. There's no difference. One more step. Divide by x. Should we cancel out those x's in the back there? No. Remember, canceling is a form of division. We have to see pure multiplication. There's subtraction in here, so we can't do that. And then, like I said, they wanted us to call it something fancy, so we're supposed to call this G inverse of x. But that means we have a new number we can't use. Zero's out. X can't be 0. So with the original, we can't put a negative 2 in. And with the inverse, we can't put a 0 in. We just have to be constantly thinking about that as they start throwing numbers at us and saying, do this, do that. So let's go to B. So my first question for you about B, come here. How do you know? Because it would make a 0 in the denominator. You can't divide by 0. You can try, but your calculator will yell at you. It'll say, can't divide by 0. So one thing you can't do in math. Take a look at B. What's the first thing they're asking us to do? Put 0 into the inverse. And what do you say to that? No can do. This is undefined. We just got done saying that's the bad one. You can't put a 0 into that one. It's not going to work. So let's go to C. What's the first thing they want us to do with this one? Can we put 0 into the original? Yeah, we can. It was just negative 2 that was bad there. So let's start there. If you put a 0 in here, it's going to be 4 over 0 plus 2. What's that? 2. Now we're not done yet, because we still have to put that into the inverse. Can we put a 2 into our inverse? Okay, so let's go find it. Let's put a 2 in there. So this will say 4 minus 2 times 2 over 2. Will be 0. 4 minus 4 is 0. 0 on the top is fine. That's what the number 0 is. 0 on the bottom is bad. So, like I said, the harder part of this objective, even though it's not listed, is going to be domain. I was thinking, all right, what's going on here? What do I have for numbers that I can use and numbers that I can't use? And that brings us to this one, where in example 7, we're talking about, for each function, find the inverse and the domain and range of the function and its inverse, and determine whether the inverse is a function. So we've got f of x equals x squared plus 3. And it says we're going to talk about the domain and range later. So I'm going to start right now thinking about the domain and range of this function. Can you think of any numbers that you can't square? 0 squared is 0. 1 squared is 1. You got them all? Can you square a fraction like 1/2? You get 1/4. You can square pi. It's ugly, but you can square it. So that means we'd get all reals. But we are not going to get all reals for range with this one. Yesterday you told me what these look like. What does an x squared look like when you graph it? Yeah, so there's going to be a whole lot of y's we don't use down here. So what we have to do is either graph this with our graphing calculator or in our noggin and figure out what y values are going to be used. X squared is a parabola. What's the plus 3 mean? On the y-axis, we have to go up 3. Now that tells us our range, because what's the lowest y value we're ever going to use? 3. So our y's have to be greater than or equal to 3. So it's not just looking at it and saying, oh, there's no square roots and there's no division. That's a big piece of it. But it's also realizing I'm supposed to get a picture of what this is in my head before I do it. Alrighty, so we're supposed to find the inverse. We know this is y. So how do you find the inverse? Okay, so it'll be x equals y squared plus 3. Subtract 3. Lee says subtract 3. Is he right?
Yep.
Okay, subtract 3. Square root. Oh, we have a problem. When you physically write that down, what do you have to do? Plus or minus. We're going to have 2 outputs on this bugger. Now we look at that, and we think, we haven't learned how to graph that yet. How are we supposed to tell them the domain and range? Well, we don't have to graph it to know. Remember, the domain of one becomes the range of the other, and they flip-flop. So we're going to label this as our inverse, plus or minus the square root of x minus 3 equals f inverse of x. But when it comes to the domain and range, we're just going to cheat and use the opposite of what we had up here. Now, for domain, we have to use x. But we're going to put x is greater than or equal to 3. What should we put in the range? All reals. All right, I got to wonder about that, right? I mean, if that's the case, we better check this out visually. I mean, if that's just supposed to flip-flop like that, let's see. Y equals, let's graph it. Second square root of x minus 3 and negative second square root of x minus 3. Graph. Zoom 6. Hey, are we using all the x's from 3 on? 3, 4, 5? Are we going to use all the y values? Well, let's see. I'll make my x's, let's see, 1,000. Let's see if it's still going up and down at 1,000. Oh boy, is it ever. Yeah, so just flipping these does the same thing as taking a peek at, flipping that domain and range. So for the got it, you're going to lead me a little bit more. All right? So this says for each function, find the inverse and the domain and range of the function and its inverse. Now, we talked about this when we first started. This has a square root. So how do we know where this is going to start? What do? We don't square it. Take a look at your notes. I had you write it on the side on the lines. When you have an even root, what are you supposed to do? So this has to be greater than or equal to 0. Because do we solve that?
Subtract 5.
Track 5? Then what? Divide by a negative. Oh, what do you have to do when you divide on inequality? Good. So this is kind of weird. The x is going to have to be less than or equal to 5. Okay. So if we don't know what this looks like visually, maybe we don't have our graphing calculator with us, we have to ask ourselves, so what happens when I put that 5 in there? What do I get? Because that's obviously important. So if we put a 5 in here, what would we get? Square root of 0, which is 0. Okay. Then we just said the only numbers we can put in are less than or equal to 5. So let's just say I put in, we want something nice here, like negative 25. I put negative 25 in here. It's going to be, well, let's go with negative 20. So negative 20, negative of negative 20 is 20. 20 plus 5 is 5. What's the square root of 25? So this would give us a positive 5. So our y's are going to start at 0, but they're going to keep going up. Now, like I said, Tyler, I'm going to take that away. Stop that. Pay attention. In the back doesn't mean you get just there and do nothing. Pay attention. If you have a calculator with, what you'll do is you'll go in here. For now, we're going to learn how to graph square roots and cube roots in just a couple of sections. For now, you go ahead and type this in and say I need negative x plus 5, zoom 6, and you'd see, hey, we're using all the x's that are less than or equal to 5. So 5, and it goes to the left forever, and it's going up forever from 0. That's the lowest spot, and it's going to go up forever. So 2 ways to do it. You can do it graphically, or you can think your way through it with the algebra. All right, we need the inverse. So now what? Okay, so this was our y. We're going to do x equals square root of negative y plus 5. So we switch the x and the y. Now what? Why? Why not? I don't know. Yeah, let's get rid of the square root. Exactly. So x squared equals negative y plus 5. Subtract 5. Divide by negative 1. That looks pretty good. Let's call it f inverse. Now we need the domain and range of that. All right. Think this is supposed to be easy. We already did the tough one. So what do we put for the domain of f inverse? So it'll be x is greater than or equal to 0. And what do we put for the range of the inverse? Y is less than or equal to 5. And I would want to check that, even if I just did it in my head. So what does this graph look like? Negative x squared plus 5. It does. And its highest point is going to be 5. So we're going to use x is greater than or equal to 0, and we're going to see y is less than or equal to 5 when we graph that. All right, do we have a problem 7.5?
Nope.
That was it?
Yep.
Okay, so I know I say this is it right now, and this is tough because this book does the graphing after they talk about domain and range. This will all come together once we see the graphing in section 6.8. We just have to wait a little bit, which I know is kind of maddening right now. So 43210 me on finding the inverses and domain and range. I know you're And I'm just going to, it's going to come. It will. When we do our graphing, it will suddenly all make sense. A lot of books do the graphing before they do all of the inverses, but this one switched that around. And I got to tell you, I do agree with them. I think it makes you start thinking a little bit outside the box, you know, because you start thinking, okay, how does this domain and range stuff work? And then when you get to that section, you're like, oh, good, I finally get it. You know, it all fits together. I understand where all those numbers are coming from.
Oh. So man.
I was